Grade 11s, welcome back to another one of our video lessons. So today we're going to continue with Unit 2, which is area on page 162. Remember last lesson we did perimeter. We learned how to calculate perimeter of triangles and rectangles and circles. Okay, so now we're going to move on to area. We're going to think about how much paint do we need to paint something, or what is the total surface area of, say, the floor. How many tiles do I need to buy to cover, say, 5 square meters and so on. So problems like that. So first we need to learn how to deal with square units. How do we convert from, say, square centimeters to square millimeters? Okay, for distances it's relatively easy because you already know that there's 100 centimeters in the meter, 1,000 meters in the kilometer, and so on. So let's now think about that first, right? So if we are talking about a distance, right, it's a one-dimensional distance, and let's say this is 1 centimeter. Okay. Now that 1 centimeter we also know is 10 millimeters. Okay, so that same centimeter is 10 millimeters. Now that conversion is easy. That's basic. We've been learning that for, well, all the years before this and even here. So the point what I'm trying to say is that now imagine we're doing a square. So it's 1 centimeter by 1 centimeter square. So this is 1 centimeter and it's also 10 millimeters. Okay. So 1 centimeter equals 10 millimeters. 1 centimeter squared means that it's a 1 centimeter by 1 centimeter, exactly like that. So that equals to 1 centimeter times 1 centimeter, which equals to 1 centimeter is 10 millimeters. So it's 10 millimeters times 10 millimeters. Okay, we multiply 10 by 10, it becomes 100. Millimeters times millimeters gives us millimeters squared. So 1 centimeter squared is equal to 100 millimeters squared. Okay, so the conversions are a little bit different because you've got to imagine that now we're talking about two-dimensional space where there's a height and a length. Okay, so guys, to do these conversions, if you ever get stuck, start with just the basic what you know. Then once you square it, square those numbers. So 10 millimeters times 10 millimeters, and that will get you here. Then multiply the numbers, get your coefficient, and then your units squared. Okay, same thing will work with meters squared and kilometers squared. So 1 kilometer equals 1,000 meters. 1 kilometer squared equals 1,000 meters squared. So it will be 1,000 squared, which is going to be what, 1 million. Okay, so it will be, so 1 square kilometer is 1 million square meters. Okay, 1,000 times 1,000, 3 zeros and 3, that's 6 zeros. All right. Okay, so let's continue. Now we know how to convert. There is a table in the textbook that tells you how to get to these conversions. And one way to approach this is to learn them off by heart. Another way is to understand how we get to the answer. Okay, so if you understand how we get to square units, you don't have to learn every single conversion, and it will make your life a lot easier, that you can just figure it out then and there. Okay. All right, guys, so let's look in the textbook on page 162. They give us a worked example and they say estimate the area of the shape on the right. So here we're not giving precise answers. They want us to estimate. So in the worked example, they lay the grid over the shape and each grid is 1 square centimeter. And then you count your centimeters and you try, or your square centimeters, and you estimate. You give me an approximate answer. Okay, if you look at exercise 4, that's exactly what we're trying to do here. So use the map of South Africa to calculate how many square blocks or how many square centimeters does each province, or how many square centimeters fit into each province. Okay, then what they say for number 2 is multiply your answers for each province by 14,400 kilometers. Okay, so what they're really saying is that 1 square centimeter on the map represents 14,400 square kilometers in each province. And then for number 3, they want you just to compare your answers from number 1 and 2 to the actual answers that you get and see how close you get. And where your answers are different, think for the reasons why they would be so different. Okay, so I mean, obviously it's got to do with estimation, and estimation is not precise. The whole point is to give me an approximate answer. Okay. Right, guys, so I want you to try exercise 4. That's just estimating how many full square centimeters fit into the map of South Africa. All right, let's now continue. Now we're going to learn how to actually use formulas to work out area for different shapes. So remember, in the previous lesson, we had a rectangle, triangle, and a circle. So we're going to go through those again in terms of area. So first, let's start with our rectangle. Here's our rectangle, length L and width W. Okay, our area of this is simply length times width. Okay, and then the units are going to be obviously square units because we're dealing with area. Okay, so guys, that's pretty straightforward. Rectangle, no issues about that. Remember, rectangles have 90 degrees. Okay, the next areas we're going to do is area of triangle, which is simply a half base times perpendicular height. Okay, so the perpendicular height is very important. Okay, so the way we get to this formula is actually from the previous formula right on top, right? So let's say we have the same rectangle here and we have the same length, and this I'm going to call height instead of width, okay? But really it's the same shape, I'm just calling it height. Now, if we want to make a right angle triangle here, what I'm going to do is I'm going to drop a perpendicular from each side. So this will essentially divide my area into two equal pieces, okay? So if I now want the area of this one right angle triangle, what I'm going to do is I'm going to rub that out, and now I have half the area of that. So that's where this formula is coming from. It's a half because we've divided the rectangle into two triangles, times breadth times height, which is the same length and width as our rectangle above. Okay. Now, what's important here when you're working out the area of a right angle triangle is that which sides do I use? Okay. So here we have base, here we have height, and this is always the perpendicular height. Perpendicular means at 90 degrees. So the two measurements that I'm using are at 90 degrees to each other. So that means that if I'm getting the area of a right angle triangle, I'm never using the hypotenuse. Why? Because there's no 90 degree there or there. So therefore, these two sides cannot be perpendicular to each other. So again, the two sides, when I'm working out area of a right angle triangle, the two sides that I'm using is the height and the length. And there must be a 90 degree angle between them. Okay. Right, so that is our area of a right angle triangle. Now, with this, we can have different looking triangles. So that is the most simplest one. That's the easiest one. But we can also have a triangle that looks like that. Okay. So that's still 90 degrees. So to work out this area, we're still going to have the perpendicular height, but now the base is going to be the entire base here, not just this bit, it's the whole thing. So that's the base times the perpendicular height. Okay, we could have another weird looking triangle that could look like this. Okay, so we could have a triangle like that. Okay. We can still work out the area of this triangle because we have a base over here, and this is still a perpendicular height. Okay, so you take that small base there, and then you take that height over there. Okay, and that's basically the three possibilities that we could have with a right angle triangle. But I don't think we'll give you any of these, but we might. All right, cool. So that is our right angle triangle. And then the last area formula is area for a circle, which is pi r squared. Okay. Again, if we have our circle, remember the only important or the only measurement of a circle we can have is the radius. Diameter is derived from the radius, so radius there. And our area formula is just pi times r squared. Okay. So pretty straightforward, put the radius in. If I give you the diameter, you have to halve that to get the radius in order to put into this formula. Okay, guys, that is the area that we're going to be dealing with. I'll give you triangles, rectangles, and circles. Remember, if I say work out a quarter area of the circle, all you do is you just put a quarter in front of the formula. because you don't want the whole thing, you only want 1 out of 4. If I say, give me a third, give me a half of the area. Or if I give you a drawing that has a quarter circle and a half circle, how do you work it out? Use the formula, everything is the same. Just give me the fraction in front of it and multiply. Okay. All right, guys, so we're going to go to the next exercise, which is exercise 5. I'm not going to run through these examples. I think we've done enough examples on the board with the different areas. We'll just go into exercise 5 and see how it goes. Right, so number 1 says a circular maze field has a radius of 400 meters. What is the area of the field in square kilometers? All right, so a lot of these questions will involve different units. So we'll say the radius is this, how many square kilometers is that? So not only do you have to work it out, but then you have to convert. Or you convert first and then you work it out. So let's do that as an example. So they say a circular maze field has a radius of 400 meters. Okay, so here's our circular maze field. It has a radius of 400 meters. Okay. Right, so they said how many square kilometers is that? So I think a better idea or a good idea would be to convert this into kilometers first, so that we're already working in the right units that they asked us for, so that we don't forget at the end to do that. Or you could work in meters and then just convert it again. But if you now work in meters, you'd have to do the square kilometer conversion from square meters to square kilometers. And that is a little bit harder than just doing the normal conversion here. So I would recommend changing that to 0.4 kilometers. Okay. How do we do that? We divide by 1,000. Okay. So I would say the area of that field equals to pi. My r I'm going to put into brackets 0.4 squared. Okay, I'm going to put that onto my calculator and it will give me whatever answer it gives me, and the units are going to be kilometers squared. Okay guys, you can do that on your calculators. I'm not going to waste time with that. Right, let's continue. Number 2, the fence around the circular field is 1.8 kilometers long. What is the area of the field? Okay, so guys, here they're really trying to trick you, okay, because they know that you know what circumference is and how to work circumference, all right? And they're saying to us that the fence has a circular field has a circumference of 1.8 kilometers. What is the area of that field? So do you see that from circumference, we have to work out radius. And once we have the radius of the field, we can stick that radius into our area formula and get the answer. Okay, so let me do this one for you, and then the rest of the exercises for you guys. There's nothing difficult here. Just stick to the formulas and you will be all right. Okay, let's do that exercise, or that question number 2. So they say that a fence around a circular field is 1.8 kilometers. So remember the formula for circumference? It was circumference is pi d or 2 pi r. Okay. But they tell us that the circumference is 1.8 kilometers. So the circumference is 1.8 kilometers, and that equals to 2 pi r. Well, what are we trying to get out? We're trying to get this radius out. So we need to get rid of this coefficient of 2 pi. How do we do that? We do inverse operations and we divide if we want to cancel terms. But if we do something to the left, we must do the same thing to the right. So since we want to get rid of these 2 pi, we divide by 2 pi and we divide this by 2 pi. Okay, that cancels with that, leaving us with radius. So radius equals 1.8 over 2 pi. Okay, again, once you get that onto your calculator, but actually, I wouldn't recommend putting this into your calculator just yet, because it's going to give you decimals and you're going to round it off. And remember, this is an intermediate calculation. They didn't ask us to find radius. They said, find the area of the circle. So I wouldn't round off this answer because it's going to throw off our final answer. Okay, so I'll keep the radius like that. So our area of the circle is, sorry guys. So our area of the circle is pi r squared, okay? But now we have the radius worked out over here. So what I'm going to do is I'm going to substitute this value for radius. So I'm going to get pi, open bracket, put that in. Sorry. Okay, so we're going to substitute radius, 1.8 over 2 pi squared. Okay, now this, your final expression, you can put into your calculators and give me the final answer, which will be square units. What kind of units? Well, what are we working in? We are working with 1.8. 1.8 was a kilometer. Therefore, this will be kilometers squared. Okay, and once you put that into a calculator, you'll get a numeric answer. And you can round it off to say 2 decimal places. Sometimes we'll tell you to how many places I want you to round it off. All right. So guys, I want you to do exercise 5, work through it, get used to working out areas. All right. Right, let's continue. The next section is just the continuation of area when we're going to say find the surface area of a particular shape. Okay, so we could have, let me find the shape. Let's say we're talking about this economics textbook, right? So I'll say, right, here's a textbook. The width is so much, the height is so much, the thickness is so much. What is the surface area of this book? Okay, so basically what you've got to understand is that a prism, or what do they call it? A horizontal base. A rectangular prism has a rectangular base. So this is a rectangular prism. Okay, why? Because we have a rectangle over here and it's been stretched out to make a prism. Okay, so if we want to find the surface area of this book, we need to realize, well, there's 6 sides to it. There's this side, there's the back side, which is the same. Then there's this side here, there's that side there. There's also this side and that side. So there's two of each side, which makes 6 different sides. So when you're working out surface area of a rectangular prism, just add all those surface areas together and you'll have your answer. Okay. Now, to work out the surface area of a circular prism or a cylinder, what you do is you take the area of your circle and you multiply it by the height of the prism. Okay, let me give you an example. So, let's say we have a circular prism that looks like this. Okay. Now, to work out the surface area, actually no. So the surface area, the surface area is this top bit over here and the bottom bit of the circle that it's standing on. Okay. So those surface areas are easy because they are circles and that's just your pi r squared. Okay. Now, how do we work out the surface area of this side, right? Or of that entire round bit? So if you think of a glass, if you roll it on the table, what is that surface area? Okay. Well, how would we work it out? Well, what is the distance? Think about it. If we take this glass and we roll it out on the table like that, okay, it's going to make a rectangle. Okay. So what do we need? What measurements do we need? We need this height over here. So you'll be given that. And you need to know this distance, which is that circular distance over there. How do we get that circular distance? Well, that's the circumference of the circle. And you'll have the radius, so you can work out the circumference. So that means it's this times that, which will give you the surface area of the side, plus you have the 2 pieces on the top and bottom to look after. Okay, guys, that's as hard as we're going to get with that. So that's surface area. If we want to find the area of these shapes, right? So for the circular prism or a cylinder, how do we find the area of it? Well, it's just going to be pi r squared, which is the area of the circle, and we're going to multiply it by the height. So times h, which is the height over here. So if we roll it out, that's your h of the rolled out bit. Okay. And this piece here is your circumference, which is 2 pi r. So the only measurements you're going to need is that radius r and the h. Okay. So guys, that's the area of a cylinder. Now the area of a rectangular prism is just your, well, volume, but we're going to get there just now in the next lesson. So we'll cover that then. All right, guys. So for this lesson, what I want you to do is exercise 4. So that's just estimating distances. Remember, it doesn't have to be exactly precise. Don't spend 10 minutes on each province trying to get it perfect. Count the whole blocks, count quarters, count halves, give me approximately how much it is. Multiply it by 14,400 kilometers squared. Compare your answers. Okay, that's exercise 4. Exercise 5, I want you to work through the surface areas, okay, of different things. Okay, and exercise 6 and 7, okay, so exercise 6, make your own cylinder. Guys, I don't want you to make your own cylinder, so we can leave that one alone. But I do want you to do exercise 7. Okay, so 6 you can skip. So it's exercise 4, exercise 5, and exercise 7. Okay, guys, thank you. Next lesson, we're going to continue with volume, which is unit 3. Thank you. I hope you enjoyed, and I'll see you later.